Solutions and solubility. Making solutions. Solutions are a homogeneous mixture with only one phase. When you make a solution, you dissolve one component into another. Solutions are clear, though not necessarily colorless. Components of a solution. The substance doing the dissolving is the solvent. The substance being dissolved is the solute. When it comes to discussing solutions and solubility, it's important to consider the types of bonds involved. You have ionic bonds, which involve the transfer of electrons. This happens between a metal and a non-metal, and it's generally extremely polar. Then you have covalent bonds. This is the sharing of electrons between two elements, and it's between a non-metal and another non-metal. These are polar and nonpolar. Polar versus nonpolar covalent. A polar covalent bond is when one element is more electronegative than the other. This results in uneven sharing of electrons and a partial charge. Nonpolar versus polar covalent. The nonpolar is a nonpolar covalent bond in which both elements have similar electronegativity. This results in even sharing of electrons and no partial charges, such as dioxygen. How do you know that something will dissolve into something else? A general rule to follow is that like dissolves like. So a polar solvent will dissolve ionic, mostly, and polar solutes. A nonpolar solvent will dissolve nonpolar solute. How much solute is in solvent? When something is unsaturated, more solute can be dissolved in the solution than what is currently dissolved. The solvent can continue to dissolve more solute. When something is saturated, the solvent has dissolved the maximum amount of solute it can handle at a given temperature. And then you have supersaturated. When something is supersaturated, a solvent has dissolved more than the maximum amount of solute that it can handle at a given temperature. This is an unusual and unstable condition. Solution saturation part 1. So what we're going to do is create solutions of varying saturation, and then test the saturation by adding a few test crystals to the solution and observing what happens. If the solution is unsaturated, then the crystals will dissolve. If the solution is saturated, then the crystals will not dissolve. What happens if the solution is supersaturated? Solubility and structure. You'll see us mix some water, which is a polar solvent, and hexane, a nonpolar solvent, with small amounts of different substances. Now we'll pick around 5 solids or liquids to do this for. From there, we're able to determine if the substance is ionic, polar, or nonpolar based on an observation of what solute dissolves in what solvent. How would you determine if it's a polar, covalent, or ionic bond? Alizarin red dye. Alizarin red dye is a very polar dye. Polar fabric is made up of polar monomers, and a nonpolar fabric will resist a polar dye. In this experiment, you'll see us use a fabric strip dyed by alizarin. Based on the intensity of the color that the strip is dyed, you should be able to determine which fabrics adhere to the dye best. And therefore, considering that alizarin red dye is very polar, it can be deduced which fabrics are more polar. If you're performing this experiment in lab, all of the hexane waste goes into the collection container under the side hood. And of course, be sure to clean up your workstations in the back. Analysis questions. When considering the mass percent of an element within a chemical, this is how you should observe. So we have NH3. What is the mass percent of nitrogen in NH3? We know the total mass of NH3 is 18 atms. The mass of nitrogen is 14 atms. So if we take 14, the part, over the whole, 18 atms, we get 0.78. You multiply this by 100 to get a percentage, and come to the realization that NH3 is 78% nitrogen.